Hello friends, myself R.D. Mahajan presenting my new video on Newton-Raphson method. Use Newton-Raphson method to find a real root of the equation x into log of x to the base 10. Here the base of log is 10 and that is equals to 1.4 correct to 3 decimal places. And as we require answer correct to 3 decimal places, fix your calculation for 3 digits. That is the first step. Then the here given equation is x log of x to the base 10 is equals to 1.4. As it is base 10, we have to use this key, log key, above which we have the term 10 raised to x. Therefore, this is the log, and another key for log ln, above which we have a term of e raised to x. Therefore, that ln stands for a natural log, which I have used in the last example, and this log log key when base is 10. And therefore, from this we get that equation, transferring this to other side, we get x log of x to the base 10 minus 1.4 equals to 0. And therefore, from this we get function fx as x log of x to the base 10 minus 1.4. Then differentiating it with respect to x, we get f dash of x as, here it is a product of two terms of x, means we have to apply product rule, UV rule. First term x, derivative of log x, it is 1 by x, and as it is base 10, applying chain rule, differentiation of that term is log e to the base, and plus second term is log x to the base 10, and derivative of x is 1, and derivative of this constant term is 0. And therefore, if you simplify it, this x get cancelled, we get log e to the base 10 plus log of x to the base 10, and log e to the base 10 is a constant value. If you find its value by 0.434, and plus log x to the base 10, and then by trial and error we find two initial guess values. Once again, as it is a log term, we are not considering the value as 0, as log 0 is minus infinity. Therefore, I am not considering the value of x as 0. Therefore, starting with x is equals to 1, we get f of 1 as, here it is 1 log 1 to the base 10 and minus 1.4, by calc is minus 1.400, a negative 1. And for x is equals to 2, we get f of 2 as, once again it is 2 log 2 to the base 10 minus 1.4 minus 0.798. Once again it is negative, means root does not lie between these two values, x is equal to 1 and x is equals to 2. We have to go for one more value. Therefore, for x is equal to 3, we get f of 3 as 3 log 3 to the base 10 minus 1.4, 0.031. Here it is positive, means root lies between 1 to 3, root lies between 2 to 3. Therefore, we consider the smallest interval, and that smallest interval is 2 to 3. Therefore, root lies between x is equal to 2 to x is equal to 3. And we have to consider one of them as x0. Therefore, for that we check the corresponding values. Here it is minus 0.798, and the second one it is 0.031. Therefore, the second value is somewhat near to 0 compared with this. Therefore, the corresponding value we consider as x0, and therefore let x0 is equals to 3, and then we apply the first step of first iteration to find out the root by Newton-Raphson method. First time we get x1 is equal to x0 minus f of x0 by f dash of x0, where x0 is 3 initial guess value, corresponding function value is 0.031, and f dash, substituting that value here, we get 0.434 plus log of 3 to the base 10, and simplified value is 0.911, and then using all these values here in this formula, we get x0 3, f of x0 is 0.031, f dash as 0.911, and if you simplify it's 2.966. Then we check whether we can call this as root or not by finding the corresponding function value, and therefore f of x1 is log x into log x, means 2.966 into log of 2.966 to the base 10 and minus 1.4, and if you find the value, it is coming as 0.000 exactly equals to 0, and as that value is exactly 0, we stop the iterative procedure. So approximate value of the root, approximate value of root is corresponding value of x. That corresponding value of x is 2.966. 2.966 as the required real root by Newton-Raphson method. And here the iteration required only one. Only one step is required to get that root of that equation. Therefore, I have discussed in detail with total 5 examples for Newton-Raphson method how we can obtain the root of algebraic equation or non-algebraic equation by applying Newton-Raphson method. In my next video, I will discuss another important method, that is Gauss elimination method to solve linear Hamilton's equation. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to receive a notification for my new videos. Thank you.